This lesson is on radical expressions and functions. First, let's look at the definition of square root. The number b is a square root of a if b squared is equal to a. Radical notation. Every positive number a has two square roots, one positive and one negative. Recall that the positive square root is called the principal square root. The symbol is called the radical sign or radical symbol. And you can see in the picture, the red is the index, the black is the radical symbol, and the blue is the radicand. Number one, what are the principal square roots of 25? In symbols, that is what it is asking. And we want the square roots, so it would be both positive 5 and negative 5. 5 times 5 is 25, negative 5 times negative 5 is 25. Number 2 is asking for the principal square root. So we only want the positive. So our answer is 5. Number 3, evaluate each square root. And in this case, we're going to go with just the principal square root. So the square root of 36, we're asking ourselves what number times itself is equal to 36. So our answer is 6. Number 4, what number times itself will give you 0.49? Well, we know that the square root of 49 would be 7. So the answer to the square root of 0.49 would be 0.7 times 0.7. So our answer is 7/10. And number 5, we want the square root of 16/25. We know that 4 times 4 is 16, 5 times 5 is 25, 4/5 times 4/5 would be 16/25. And number 6, we want to approximate the square root of 38 to the nearest hundredth. In order to do this, you will notice that the square root symbol is above the x squared. So we need to press second and then x squared, and that'll give us the radical sign. And then type in the radicand and press enter. This calculator is set up to be in math print mode, so it's going to simplify the radical, but we need a decimal. So right above the enter sign, or the enter button, there's this toggle switch. Looks like a double arrow. If you press it, it will convert the square root to a decimal. So we want to round to the nearest hundredth. So since this is a 4, we're not going to round up. So our answer is 16.16. So before I move on, let's check our answers to 3, 4, and 5. So if we want the square root of 36, 6, the square root of 0.49, and the square root, I would use my fraction button. It would be helpful if I typed in 16. And there we go. All right, this next section is a little more information than we need right now, but just follow along and kind of look for a pattern. So for every number x, the square root of x squared is equal to the absolute value of x. And I like to call this the even, odd rule. So if you are taking an even root of an even power and end up with an odd power, you need absolute value around the answer. So we're going to kind of stretch your thinking right now, but look for a pattern, see what's going on here. So there's a little 2 in this index that you do not see. So we are taking the square root of a to the 6th. A to the 6th means I have a times itself 6 times. The index tells me I need 2 in each of my groups. So how many groups of 2 are in 6? 3. So my answer is a cubed. But because I have an even index of 2, an even exponent of 6, and the result is an odd exponent, 3, we need absolute values around our answer. Square root of b to the 10th. So I wrote in the 2, so we have an even root, an even power. How many groups of 2 are in 10? 10 divided by 2 is 5. We have an even root, an even power, and the result is odd, so we need absolute value. Same with the next one. We're taking the square root of a perfect square. So if I wrote this out, I would have x plus 5 times x plus 5. So my answer is just the radican, which is x plus 5. Follows the pattern. If you're taking the square root of a perfect square, you get the radican, and you need absolute values. Factoring never goes away. So we get the pleasure of factoring. And now this is just like the previous example. We're taking the square root of a perfect square. So our answer is just the radican, because we have 2 of the same factors. We want the 4th root of c to the 4th. How many groups of 4 are in 4? 1. So this would just be c to the 1st, and we would need absolute values. If we're taking the 6th root of d to the 18th, we have an even, we have an even. How many groups of 6 are in 18? 3. So we have an even 6, an even 18, and an odd 3. So we need absolute value. But what I don't want you to do is to be all confused right now, because the key to this is reading the directions. Be sure to read the directions to see if the variable represents any real number, in which case you would need the absolute value signs. If the directions state that all variables are positive, then the absolute value signs are not needed. And we will most often use variables that are positive. Cubed root. The number b is a cubed root of a if b cubed is equal to a. So we are looking for the cubed root of 27. We're asking ourselves, what number times itself 3 times will give you 27? And the answer is 3. If we want the cubed root of 1/8, what number times itself 3 times will give you 1/8? And that will be 1/2. Before we go any further, let's figure out how to do this on our calculator. Since we want the cubed root, we need to press 3. And then you might notice that above the exponent or the up key, there's a little x with the radical symbol. So we need to go second and that key, and you will notice that the 3 is now an index. It gets smaller. And then we'll type in 27 and press enter. So our answer is 3. Likewise, we can find the cubed root of 1/8. And the answer is 1/2. Number 9, we need the cubed root of 343. Sorry about that. So we're trying to figure out what number times itself 3 times will give us 343. We can use our calculator. The cubed root 343 is equal to 7. So that means that 7 times 7 times 7 is 343. So our answer is 7. So now we want the cubed root of negative 125. Cubed root of negative 125 is negative 5, because negative 5 times negative 5 times negative 5 is equal to a negative 125. So our answer is negative 5. Number 11, the cubed root of negative 8x cubed. So what number times itself 3 times will give us negative 8? We know that that is negative 2. And if not, we can use our calculator. 3, second, up arrow, negative 8. It's negative 2. And then we're taking the cubed root of x cubed. So if I write out my 3 x's, how many groups of 3 are in 3, which would be 1. So my answer is negative 2x. Number 12, the cubed root of 125. Well, we did this up on number 10. We did the negative, so we know that the cubed root of 125 would be a positive 5, because 5 times 5 times 5 is 125. And then we're taking the cubed root of a cube, which will just give you the radicand. So my answer is 5x plus 6. You can leave your answer this way, or you can multiply it. Either answer is acceptable. Number 13, we're looking for the 9th root. We're looking for the same number that's multiplied by itself 9 times to give you 512. So we can use our calculator. We would go 9, second up arrow, 512, and press enter. Tells me the answer is 2. And then if I'm taking the 9th root of an exponent of 9, I just have the radicand, because there is one group of 9 in 9. And we can leave our answer like that, or we can multiply it. We can distribute. And number 14, we want to use our calculator, approximate the cubed root of 38 to the nearest hundredth. 3, second. So this is 3.361. So we look at the 1. It's not going to round our answer up. So our answer is 3.36, or 3 36/100. All right, let's take a look at some functions. Number 15, if possible, evaluate f of 1 and f of negative 2 for each f of x. So this is plug and chug. So if we want to find f of 1, we're just going to substitute 1 in for x. That's all there is to it. Now let's find f of negative 2. So the square root of negative 9. You need to multiply the same number together to get negative 9. Not going to happen because a positive times a positive is a positive, and a negative times a negative is a positive. So we have no real solution. So let's try example B. So we have the square root of 6 and f of negative 2. Again, when you're substituting in a number for a variable with an exponent, you need to use parentheses. So we have the square root of 9, and the square root of 9 is 3. When are you ever going to use this? Well, right now. Here we go. Calculate the hang time for a ball that is kicked 75 feet into the air. The time t in seconds is given by the function t of x is equal to 1/2 square root of x, where x is the height in feet. So we want to calculate the hang time for a ball that is kicked 75 feet in the air. T is in seconds, x is in feet. So we're going to find t of 75. So I will use my calculator. I will take 1/2 times the square root of 75. And this calculator is going to simplify it, but I need a decimal. So I'm going to press the toggle switch, and it's going to tell me that it is approximately 4.33 seconds. Because t is in seconds. So the second part of this, does the hang time double when the ball is kicked twice as high? Well, that means if we find t of 150 and it's double what we just found, then we would say yes. So let's figure this out. And this is approximately 6.12 seconds. So does the hang time double when it's kicked twice as high? And the answer is no. Because we would need 8.6. All right. Let's venture back to the world of domain. Back in probably week 2, a long time ago in chapter 7, you had to find the domain of a rational expression. That is when you had x in the denominator. So a square root is also going to restrict your domain because what's under the radical sign has to be greater than or equal to 0. So find the domain, write your answer in interval notation. So when working with square roots, to find the domain, you are always going to set the radicand greater than or equal to 0. We can take the square root of 0, but the square root of -1 is not a real number. And we'll venture down that lesson later on. So here we go. So we know that x has to be greater than or equal to -12. So we will include -12 to infinity. To find the domain of a square root, set the radicand greater than or equal to 0 and solve for x. Know that when you divide both sides of an inequality by a negative, you must reverse the inequality sign. So x is less than or equal to 5/7. So that's -infinity to 5/7. Set the radicand greater than or equal to 0. X is greater than or equal to 12. As an interval, we're going from 12 to infinity. And number 20, x squared plus 9 greater than or equal to 0. Think logically. Is x squared plus 9 ever going to be a negative? No. So in this case, the domain is all real numbers because there are no restrictions because we have an x squared. We have an x squared plus 9. All right, so number 21, this goes back to chapter 7. We have a fraction with a variable in the denominator. So the domain will be restricted because 7x minus 3 cannot equal 0. So we'll add 3 to both sides, divide both sides by 7. X cannot equal 3/7. So if I draw this on a number line just to help me graph it, or to get the interval, I mean, I can have every number except 3/7. So as an interval, it's from -infinity to 3/7, union with 3/7 to infinity. Okay, that does it for this particular lesson. I'm going to make a separate video on these review problems, but these review problems were attached to these notes, and I will point out that number 1 needs to be corrected. That should be the correct equation. So come back next time and I will work these review problems out. Thanks for watching.